Hello. Today I will be drinking coffee and coding. But it's going to be a little bit longer video because I just want to share some ideas around Waylay rules engine and Claude and other things. But before that, I wanted to sneak Shannon a little bit because it was a pretty smart guy, to be honest with you. And in a way, what we are doing resembles a Shannon theory. I'm not going to talk a lot about it, but basically what this formula says is that as I'm saying things, things are less uncertain in a way. But the measurement of uncertainty, it depends on the probability of information that I'm giving to you, how you're going to be surprised by it. If you're not so surprised by it, well, you're not adding that much of information, or you're a little bit even not so certain about what the heck I'm going to be talking about. Yeah. And in a way, the same things happen to spoken languages. What I mean by that is that that was actually interesting study done some time back, and I just want to bring it here to attention, that the transmission rate of information for humans is about 39 bits, but it's not the same per syllable, the amount of information we are transmitting from the language to language. So if I speak Japanese or Thai, they're very different. Japanese, if you listen to it, it's actually very fast language because the amount of information that it's packed inside the syllable, it's actually very low. Unlike in Thai, which is actually pretty packed in that sense, so you can actually speak slower and still convey the same amount of information. And that's actually pretty interesting. Anyway, not gonna be trying to learn Thai today, but the funny thing is that there is another guy who actually took that and look at that in relation to coding languages. And there is an old joke that I'm too old to code in Java because it takes ages to write something down. And if you look at interpreter languages, they are packed by information. You need less to write code to convey the same information. And that is true for all interpreters because they're somehow trying to follow this Shannon way of thinking is that I can try to convey as much as possible in as less characters as required. And that's also the reason, by the way, why majority of the LLMs are very good in producing the code in Python, by the way, or JavaScript, for the same reason. Now, when we want to convey the message to LLM to produce code, we can actually do the thing as we are doing it now. But then the problem is that if the LLM has to convey message back to you what it's doing, you are again coming back to that capacity overload, or rather the limit that you have in your brain. So what are we trying to do in Waylay Rules Engine, using the same analogy with Python or Thai language, to have it as compressed as possible in relation how we convey the logic. Yeah. Of course, you can always write down in any coding language a logic, but again, it takes a little bit longer to process that, to confirm from the human side of things that actually does the thing as it's supposed to do. And by the way, when you ask the LLM again back, so what are you doing? It has to do the reverse calculation, if you like, to explain it in a human language, so to speak. Now, what is interesting about Waylay abstraction is that it follows either you drag and drop things or you're describing your diagram in a kind of a JSON, but it's packed by information. It has the sensors which can have a code, it has a condition, has a logical gates, and you're kind of conveying that logic in a way that it's easy for humans to understand. What is actually interesting is that also then it's easy for LLM to understand the kind of information or kind of logic you're trying to convey through your system. And in that sense, we favor the clarity over clutter, and it actually lets you move fast without losing the meaning somewhere in process. Now, the fun part is then if you look at the people who can use our system, they can be Thai people because they can be just saying, okay, this is what I mean by building this logic together like an experts. Or you can also have Japanese guys like or Java guys who can still then code in a C or Java and then convey that message inside the sensor applications or other codes which are very packed with information but they are very isolated in a sense. Yeah. Now That was a little bit of a theoretical thing. I will share later on the complete article, but let me explain you what we mean by that in, let's say, in the sense of programming. So what we have done is that we have exposed our capability through the MCP that is now running locally, and I will be conveying the message to Claude of how we wire the logic. Now, the interesting stuff is that when you want to tell LLMs to train it on your own thing, there are two ways typically people do that. Either for the fine tuning, that is to say that some weights are kind of changed so that your answers are preferred versus some other answers that are already in the set, or through the prompt engineering. That is to say, I'm giving you some examples, so take this into account before you're answering. Now, what I found difficult is that if I use the prompt engineering on our framework, basically what I'm doing, I'm dumping documentation in the prompt. You can do that, but we found a better way to do that. That is to say, I'm going to give a couple of examples straight into the code in this example and tell it, okay, use this information to figure out what on earth you are doing with our framework. I would just say, take these templates, and I'm going to now list a couple of these. This is the one that is used to train LLM how we do the logical buildings. One how we do the basically the complete rule, and I will take the same rule twice because one it's used by a rule that actually can stream process the stream data, and the other one it's kind of like in RPA context doing the same thing and analyze this. Now the interesting thing is that I am basically can set a set of library of templates to train them on a specific problem I have, because my problem that I want to actually address here is to create advanced logic on the HVAC troubleshooting which is now only based on three parameters, which is something like temperature, airflow, and energy, and then use some additional components to improve the logic of my implementation. So what we are seeing here now is that it's looking at these three templates, um, and it's looking at the set of variables which are used there. Then what you see here in the condition, it's kind of learning how we are doing the mathematical computation, the reasoning, and more or less it gives you the comparison of these two templates, um, and this is pretty much what it does. Yeah. So now that we have that, okay. So what I'm gonna do now is I'm just gonna say take V1 template. Okay, it's still reasoning. Fine, fine, fine. That's okay. So it figures out that V template, it's let's say evolution of the first one. Take V1 template and extend it to monitor additional params that make it more complete for HVAC tests, diagnostic tests. Stick tests, and let's see what happens. Okay, so it's going to look at through its own database of knowledge in relation to what it knows about the um, different sort of monitoring things. So, okay, so it's picking up my temperature right now and airflow as it is. Okay, now it's adding humidity into these things. Fine. It's adding the static pressure. Fine. Supply temperature. So again, what is it doing now? It's the Claude, of course, it knows a lot about HVACs and monitoring. Now it has learned through only three examples. I could have also shown in two, how we are wiring the logic. And again, using the Thai or a Python metaphor, it knows how we compress and how we are transforming that knowledge in our framework. We are still in a human interface and it has figured out how to communicate to me what it is doing. And now it's going to create a new template, which is going to be deployed. So who is kind of busy. Look at all of these things. It's creating all sorts of combinations. So notice this is how we are actually wiring things together. If this and that or that and that, we can actually have a means to combine all these outcomes and provide decisions on top of that. So boy, it's also doing all sort of other things. So let's see what happens. How is this going to be called? Okay, good. So he has created a new template. Let's see what is in there. Okay, there you go. That's very interesting. Okay, so he has added additional checks. Very good. So good. Now it's actually explaining to me again in my human interface what it is doing based on the logic and other things. So it's giving me diagnostic output. Nice. So it's apparently compliant to some other things and predictive maintenance and all of set operational advantages. Nice. What I'm gonna do now, just say run it with some test data and provide me a test report. Okay, so had it 25 parameters. Very nice. Okay, so it's just kind of repeating all that stuff that I see on the right-hand side. That's fine. So let me do another magic. So what it needs to do now is to prove to me that is indeed correct all of these things. So it's now going to kick another interface of Waylay, which is to actually push the real data. So we're going to start seeing these things here. So, okay, there you go. So has now identified test data. Okay, he also is correcting a template because he figured it out. Okay, there was some problems with the template itself. Nice, so it does the auto correction, which is also very interesting, is because what it's also doing, it's our MCP, it's returning the errors to the reasoning engine such it can correct itself in the assumption what it is doing. Yeah. So basically what it's doing now, it's actually validating the completeness of the template, and as well what you actually see here is that it says, okay, the resource is not found. So it says, okay, hold on a sec, I have to actually redo my template. Okay, so it's done the tests with different data sets, and these are the results. Okay, so now it's testing the second part. That's what we are seeing here. So it has the different units to test. Okay, so it says that it has found the critical issues. Isn't it amazing? I'm still drinking coffee, and I'm gonna have a new template that is people remember unit testing and integration tests? Boy, it's all done. Wow. Okay, so I can deploy that, integrate, and that's it. So it took me about a couple of minutes to create a new template, add new diagnostic rules, create alarms, do the unit testing, and my template, it's already ready to be deployed um, immediately. Thank you very much, and till the next time. Bye-bye.